Hi everyone, this is part 2 of the unit circle. So in the first video, we filled in all of the degrees, and now we're going to fill in all the radians. So first, this is 180 degrees, and this is 360 degrees. And I'm going to change those to radians. Remember the unit multiplier for converting to radians was multiplying by pi over 180 degrees. So the 180s would cancel out, and you would just get pi. I'm going to fill that one in. That 180 degrees is pi radians. And then I'm also going to convert 360 degrees by using the same unit multiplier, pi over 180. This time, 360 divided by 180 is 2. So we get 2 pi for the number of radians. And what I want to say is that we're not going to take every single degree that we filled in part 1 and convert them to radians in this way. You can do that. It would be right. You would get the right answers, but it would just be really, really time consuming. So I love using this trick, which just uses the idea of fractions. And I'm going to go through it. It might be helpful to watch this a few times just to make sure it makes sense to you. So first, I want to talk about when we went around the unit circle in 30 degrees. So we had 30, this was 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So going around by 30 degrees gave us the degrees for every single branch of the unit circle except for those middle branches. So I did not highlight those, but I'm talking about this one, this one, this one, and this one. And what I think is a really great way for filling in the radians of the unit circle is to think about, remember, we're always starting from here. So from here to pi, if you just look at that section and you look at the yellow highlights that I made and kind of think of this as a pizza, the question is, how many pizza slices do you see from 0 to 180 degrees, or 0 to pi radians? And you should see 6 slices of pizza. Here's 1, 2, 3, 4, 5, 6. Right? You can see, let me erase this. Here's 1, 2, 3, 4, 5, 6 slices of pizza. And so what you can do is say that you know from 0 to pi, if you're going around in 6 pieces, that this is going to be 1 pi over 6 and 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. And I'm going to actually keep going. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So it's that idea that if you are cutting something into 6 pieces, 1, 2, 3, 4, 5, 6, this is 1 over 6. Each one is 1 over 6. Right? So this is 1 over 6. If I look at 2 of them, it's 2 over 6. If I look at 3 of them, it's 3 over 6, etc. So that is the idea, and that fills in all the radians except for 4 of them. One thing is that you do have to reduce a little bit. So 2 pi over 6 is going to become pi over 3 when you reduce that fraction. 3 pi over 6 is going to become pi over 2 when you reduce the fraction. 4 pi over 6 is 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 would just give you pi because the 6's would cancel, and that's filled in already. 7 pi over 6 doesn't reduce. 8 pi over 6 would be 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 would be 5 pi over 3. 11 pi over 6 doesn't reduce, and 12 pi over 6 reduces to 2 pi. All right. I'm going to erase all of that for the next part, or just go to another blank unit circle. So let me see if I can do that. Okay, and then the very last one, so we know this is 0 radians, this is pi radians. The very last thing that we did is when we went around by 45 degrees. So if you go around by 45 degrees, you would be 45, 90. It's basically hitting all those middle branches, right? 45 degrees is halfway between 0 and 90. So the first time you go by 45 degrees, you would be at that middle branch, and then another 45 degrees would put you at 90, then you'd go to that middle branch, and then to 180, etc. So the shortcut for this one is to look between 0 and pi and think about how many pizza slices you see from 0 to pi. And hopefully you are seeing 4 pizza slices there. Here's 1, 2, 3, 4. And so in terms of fractions, if you have something cut up into 4 pieces, the first one is going to be 1 pi over 4. The second one is 2 pi over 4. Then you have 3 pi over 4 and 4 pi over 4. And we're going to keep going. 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So first thing is there's reducing here as well. So 2 pi over 4 is pi over 2. 4 pi over 4, the 4's cancel, you get pi. 5 pi over 4 can't be reduced. 6 pi over 4 is 3 pi over 2. 7 pi over 4 doesn't reduce. 8 pi over 4 reduces to 2 pi because 8 divided by 4 is 2. So that gives you the remaining radian measures of the unit circle. And the last thing I want to mention is some of these were filled in already. So we had this 2 pi over, like we had that radian measure already. We also had this one, and we also had this one. And it looked slightly different when we were going around by pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, etc. However, they reduce to the same thing. So 1 pi over 6, 2, so we had 3 pi over 6 in the previous example, but that still reduces to pi over 2. So even though there's that overlap, it's still reducing to the same thing. 4 pi over 4 in the last time we were going around the unit circle was 6 pi over 6, but it's still reduced to just pi. And similarly for the 6 pi over 4, reducing to 3 pi over 2. So that is the trick for filling in the radians. I would say that this radian trick using fractions and filling in the radians is kind of the thing about the unit circle that needs the most repeating. It's just kind of a strange thing. So students often ask to have that trick repeated, which is totally fine because it's a little bit strange. So if it seems a little bit weird, it's totally fine and normal. It's something that we can go over a few times, but there it is for the first time, unless you have seen that before. That is how to fill in all the radian measures of the unit circle.